All right, so looking at the inscribed angle, why is it different from the other angle we just finished studying? Well, your central angle usually hits the center. So this is the one we looked at before. So before we said that if this was 50, then the measurement of the arc was also 50 degrees, right? That's what our test was just over. But now what we're looking at is we're looking at the angle that's over here. So all 3 points of your angle are actually on your circle. So that's the difference, is that now it's getting pulled back onto the circle. So with that said, if you look at the width of the angle, do you think the angles are going to be the same? Look at your arc. Do you think the arcs are or do you think these arcs are the same measurement? No. So there is a rule for it. So for inscribed angles, anytime you're looking for an inscribed angle, so if you're looking for angle 1, this is how you read the formulas. These are your formulas. To find angle 1, you're going to take half of the measurement of arc A to B. So here's arc A to B. We're going to take half of that to find angle 1. So if you have the arc and you're trying to find the angle, you're taking half. In reverse, if you have the angle and you're looking for the arc, you're going to do the opposite. What's the opposite of dividing by 2 or halving? Multiplying by 2. So if you have the angle and you're looking for the arc, you're going to multiply by 2. All right. So if you're going in, you divide by 2. If you're going out, you're multiplying by 2. And that's all it is with inscribed angles. Okay. All right. So look at the first one. Example 1A. If I'm looking for angle B, and angle B is here, and you have the arc, do you think we're going to multiply by 2 or divide by 2? Divide by 2. Good. So we'll do 60 divided by 2 is going to give me angle B. What's the measurement of angle B? 30 degrees. And that's it. So unlike the last unit, where it's not going to be exactly, you're going to be halving or doubling, okay? All right, look at the next one. I'm going to look for arc R to T. You're looking for the arc, and you have the angle. Do you think I'm going to half or double if I'm going out? Double. Good. So what's 2 times 63? What was that? 126 would be the measurement of arc R to T. So this would be 126 degrees. All right, and let's do the last one. So the last one is looking for W to X. This one's going to have multiple steps, okay? So look, you have the 57, and look, this is angle 57, right? So what I'm going to do is I'm going to take this line, and I'm going to pull it out. I'm going to take this line, and I'm going to pull this one out. So that angle is going to help me find the intercepted arc that's between these two lines. So look at what's between the two lines. It's W to Y. Is it W to X? Because that's what they're asking for. Was it W to X? No, it's W to Y. So what we can do is we can take 57. Do you think I'm going to half it or double it if I'm looking for this arc? Double it. Good. So let's do 57 times 2. What's 57 times 2? 114. Now this is 114. But their question, you've got to read the question carefully. They're looking for WX. They're looking or are interested in this arc. We'll call this A. They're interested in that letter A. So what can y'all tell me about the circle? What else do we know about this picture? X to Y is the diameter. That's why I was erasing that. Good job. X to Y is the diameter. This is your diameter. What did it just do to the circle then? It cut it in half. That means this side equals 180, but also this side should equal 180. And we already have 114. So what should be our next step? Good. So the second step, we'll do 180, take away 114. What's our difference? 66 degrees, and that's our arc. Okay, so I labeled the steps. The first step was to double, right, to find the arc that we could find. And then the second step was to find the other arc, okay? All right, so I'm going to give you a moment to try the examples. All right, let's see. Who can give me the answer to number 1? How do we find X? What do we want to do? Divide it by 2. Good, bless you. So take 78, divide it by 2, and what do we get? 39, good. So X is 39 degrees. All right, someone different. What do we want to do for B? Multiply it by 2. So 96 times 2, what does that get us? 192 degrees. All right, and who wants to do the last one? So many volunteers. Go ahead, Sophie. Divided by 2, good. 124 divided by 2, that gets us 62 degrees, good. All right, when you're ready, we'll go over to the right side. So on the right side, it's the same idea where it's multiple steps. Okay, well, the key thing is to extend those lines. So look at example 2. So here, it says, we're going to find angle X, which is here, angle Y, which is here. We're also going to find X to Y, and then we're going to find Z to X. All right, so do y'all want to mess with the 95 or the 57 first? 57, all right, thank you for picking. All right, so this is angle 57. What you're going to do is you're going to extend this all the way out, and this tells you what arc you can find. What arc can I find? What arc is in between these two lines? X and Y, all right? So X to Y. You see how it's in between the two lines? 57 is going to help me find X to Y. So what do I need to do to get X to Y? Multiply 57 by 2. Good. So X to Y will be 57 times 2. And I'm going to write what we're doing right there on that line. What does that get us? 114. All right, so this is 114 degrees. And I'm going to place it here because you will need it. All right, now let's deal with the 95. The 95 is the arc. So here's your arc. This arc is going to help you find the angle inside. So exactly where it stops, you're going to go to the corner opposite of it. What angle is it going to help me find, X or Y? It's going to help me find X. That's the one it's pointing to. It's pointing to this angle here. So what should I do to the 95? Divide it by 2. Good. So to find angle X, we're going to do 95 divided by 2. And that's 47.5 degrees. So I'm going to write 47.5 in there. 47.5 degrees. All right. So now we just have to find 2 more things. Do y'all want to find the arc or the last angle? The last angle. All right. What type of shape is inside? What type of shape is inside the circle? A triangle. How many angles does a triangle add up to? Or how many degrees does it add up to? 180. Good. So to find angle Y, this last angle right here, I'll mark it in blue. To find this last angle, we're going to take the 2 angles inside and subtract it from 180. So to get angle Y, I'm going to do 180, take away 57, take away 47.5. That's going to give me my angle. What do we get when we subtract 57 and 47.5 from 180? What is it? 75.5 degrees. So 75.5 degrees. All right, we don't need it for the last step. Well, I guess you could. If you place it here, you can use it for the last step, but you can do that last step 2 different ways. So the last thing I have to find to be done with this problem is I have to find this arc right here. We can do it 2 different ways. What do all the arcs add up to? 360. You could also, so what we could do is we can take 360 and subtract 114 and subtract 95, or you can look at the angle that's across the arc. Again, you're just going to go across. You can use that angle and do what to it? Multiply it by 2. It's whichever one you want to do. What do y'all want to do as a class? Do y'all want to subtract from 180 or do you just want to double? Just double? Okay, so let's do 2 times 75.5. What does that get us? 151? 151 degrees. And that was that question mark. All right, so we did want to see what would we get if we subtracted it from 360. So if you wanted to do it the other way, we could have done 360, take away 114, and then take away 95. And we should have came out with that exact same answer, okay? So that would have been the other way to do it. So practice 2, you guys were already working on it. What did y'all find first? Did y'all miss with the 50 or the 160? The 50. Ajani, what did you do with that 50? And what did that help you find? Q to S, correct. So here's the 50. So if I extend it, I'm going to mess with the 50 to help me find this arc. So 50 times 2 would be 100. So this is going to give me Q to S. So 2 times 50 was 100 degrees. All right. Tristan, what do you want to do next? Want to mess with the 160? All right, tell me, which corner is across the 160? The Q or the S? And here's your 160. What is across this arc here? The Q, good. So when we're going in, are we going to half it or double it? What do you think, Tristan? Half it, good. So we're going to take the 160. We're going to divide it by 2, and what does that get us? Mm-hmm. 80 degrees, good. So that would be 80, so this angle would be 80 degrees. All right, let's look at the next one. Rosalind, what did you find next, Rosalind? Or what can we find next? If you didn't get that far, what can we find next? What did you want to do? We can either find the question mark, which is here, or you can find the arc. Which one do you want to do? The arc, good. What should all the arcs add up to? 360, all right? So Rosalind, all of it should add 360. So for Q to R, we're going to do 360, and you're going to take away the other two arcs. We have the arc of 160, and we have the arc of 100. What would that get us? 360 minus 160, and then minus 100. What'd you get? 100 degrees, good. So we're going to put 100 degrees here. All right, so now we have all the angles. Now the last step, it's really up to you. You can use the 100 to find the question mark, or you can use the triangle. Which one do you want to do, Audrina? Do you want to use the triangle, or do you want to use the arc? To find this angle, do you want to use the arc to find the angle, or do you want to use the triangle? Good, what do triangles add up to? 180, good. So what are we going to do? We're going to take 180, and what are we subtracting from it? 50 and 80, good. What does that get us? 50 degrees, good. So that last one would be 50 degrees. All right, you could have also taken the 100, divided it by 2, and that would have given you the 50 as well. All right. Next theorem. The theorem we're looking at here just says that if two inscribed angles share the same arc, they have to be the same. That's all it is. All right, so let me zoom into the picture. So here we have two inscribed angles. We have angle C and angle B, right? Here's angle C, and here's angle B. So all it's saying is that if I have B here, and look, I'm going to just extend B in red, and then I'm going to extend C in blue. You see how they're meeting at the same points? You see how the arc in between both red and blue lines is that green arc? If they have that the same, then these two angles have to be the same. So if this was 60, automatically this is 60. All right, as long as they share the same arc, these two will have to be the same. So with that said, I'm looking for angle or arc K to N, but then I'm also looking for angle KM to N. Let me do the angle first. So this is 3 letters, and the way you trace it in that order. Do not make a triangle. K, M to N. They're looking for this angle right there. What did I just say? That if they share the same arc, they have to be what to each other? The same. So what's angle M? 52, good. So the measurement of angle KM to N is just 52 degrees. Now, regardless, you can use either one. What should we do to that angle to find the arc? Double it. So 2 times 52, what does that get us? 104. And that would be the arc of K to N. All right, so I'm going to have you try the same thing on the right side. Same thing on the right side. You're going to look for the angle. You're going to look for the arc, okay? Look for the angle. Look for the arc. So some of you may want to write out the example. That way you at least have the example there. All right, Davian, what do you think? What do you think I should do to this arc to find angle X? Divided by 2. So 54 divided by 2, what does that get us? What'd you get? 27? Okay, 27 degrees. And that was angle X, right? So what should we do to figure out angle Y then? Do we have to do anything? What do we say about these two angles? They're going to be what? They're going to be the same. So angle Y is going to also be 27 degrees. So there's no point in doing double the work, right? All right, when you're ready, we'll go over to the back side. I'm going to talk about that picture down at the bottom here for just a second. All right, so one thing you want to remember is that when you have a diameter, what does the diameter do to a circle again? It cuts it in half, and this whole half has to be how many degrees? 180 degrees, right? So if you think about it, if I was to extend these legs here, and that was 180, you would just do what to it? You would divide it by 2. Well, when you divide it by 2, you get 90. So with that said, anytime you have a triangle and it's drawn inside half of a circle, it has to be a 90 degrees. Doesn't matter where the other point is at. So this is what I'm trying to say with that. So if I have this semicircle, or half of the circle, and I decide to draw my triangle like this instead, this has to be 90. Doesn't matter where I draw it, that's going to have to be 90 degrees because it's opening up at the diameter, and that half has to be the 180. So if you see a triangle inside drawn inside half of the circle, automatically it has to be a right triangle. Okay? All right. Let's look at this one here. So with that said, what should be the measurement of arc AD to B? What do y'all think? It's 180. Again, here's your angle. I'm going to extend it. Anything between it is you're going to use the angle that's across from it, the inscribed angle. And we have the 90 there. So you could, if you don't recognize it, you can do 90 times 2. I can get it. And that'll give us 180. But if you remember that that's a right triangle and that it's a semicircle, 180 should be something we can come up with fairly quickly. All right, look at the last thing. What about B to C? How can I find the arc of B to C? This goes back to the first example. How can I find arc B to C? What should we do? Multiply what by 2? 35, right? If you extend the 35s here, it's at that arc. So what's 35 times 2? 70, good. So 70 would be the measurement of arc B to C. All right, so I'm going to have you go down. We're going to talk about the next thing. All right, we're going to skip that practice real quick. Let's come down to the quadrilateral. A quadrilateral, if it's inscribed inside a circle, we kind of saw this when we were talking about circumference and radius and diameter. Now what we're saying is that if you have a quadrilateral, the opposite angles are going to add up to 180. So for example, angle L and angle N should equal 180 degrees, as well as K and M. So opposite angles, as long as the 4 points are on the circle, will add up to 180. Well, they'll be supplementary. So here we have a figure that has a quadrilateral inscribed inside a circle. Find the following. Well, what is opposite of X? 80. So we'll take X plus 80, and we'll set it equal to what? The rule says they have to add up to 180. So we subtract the 80 degrees. And what is X equal to? 100 degrees. All right, what am I going to pair up with the Y? 71. All right, so we were with the Y, right? So let's do Y plus 71 in case you need it. Y plus 71 equals 180. So we should subtract the 71. What's our difference of 71 and 180? 109 degrees. All right, so let's see how y'all did on the practice. I apologize for that disconnection. All right, what am I putting with the X here? April. What should go with 68, April? X, good. So you should do 68 plus X equals 180. And what do I want to do with the 68? Subtract it. And can you subtract it for me? What do you get for X? $112, good. All right, then let's do the last one with the Y, Avery. What's going to go with the Y, Avery? 104, good, bless you. Y plus 104 equals 180. What should I do with the 104? Subtract it, Avery. Can you subtract it for me, Avery? What do we get for that Y value?
$76.
76, good, 76 degrees. All right, so on the last example, we're just putting it all together, all of it. Everything we've done, all in one picture. Ready? All right, last one. So here we have a quadrilateral inscribed inside a circle. I'm having you find everything. So look at all your numbers. What do y'all want to deal with first? Do y'all want to deal with the 126? Do you want to look at the 90? Do you want to look at the 93? 93, okay. So you're going to look at the 93 and you're going to say, okay, so here's 93. I want you to extend the legs out all the way out, the chords. And 93, whatever we get from it, is going to find this entire arc. It's going to find this whole thing. So what do I want to do with the 93? Multiply it by 2. Good. So 93 times 2, what does that get us? 186. Now, 186 is that whole teal arc. So can I figure out R to S instead? So if all of this here, I'm going to do a dashed arc. If this dashed arc is 186 degrees, how do I find this little arc?
You add the subtract 90 and then subtract 360.
We could, but then, look, Ian, I don't have that little piece. Yes, Evan? Oh, go ahead. Divide what?
2.
I know y'all want to divide by 2. It looks like it's right in the middle, right? But we have 90 here, and the whole thing's 186. 186 minus 90. Good. So let's do 186. Let's take away 90. That's going to give us what? 96 degrees. So this is 96 degrees. The reason I want you to find it is because I don't know if we'll need it, so we can go ahead and just find it and be done with it. All right, so let's see. What else can we look for? We can look for S. How can I find S? With what angle? Right, these two should add up to how much? 180, good. So where's angle S at? Let me put it over here. So for angle S, we're just gonna do X plus 93 equals 180. Take away 93, and angle S is how much? 87. All right, so I'm gonna put 87 here. Did we find P to R? They didn't ask for P to R. They asked for S to R. S to R was 96. We found this one. This one was 96 degrees. All right, so now, Ian, Q to R, Ian. How can I find Q to R? Tell me what you were telling me earlier. And then do what to it? Yeah, so to find this little piece, he says add everything on the outside and set it and subtract it from 360. Now, we can subtract the whole thing. What's the whole thing already? The whole thing is 186, and then subtract 126. That way you're not subtracting 3. So for R, Q to R, we're going to do 360. We'll subtract 186, and we'll subtract 126. What does that give us for Q to R? That's 2, 3, 48. So 48 degrees. All right, we just got a couple more things to find. Do y'all want to find P or do you want to find R? It doesn't matter which one we find. R? Okay, so they have spoken. They want R, so R's here. So the way you find it, again, you see where the angle is. You're going to have to extend that out. And what is everything in between these two chords? 90 and 126. So what's 90 plus 126? 216, she says. All right, so if this is 216, how do I use that to figure out angle R? What do y'all think? Divided by 2? All right, so 216 divided by 2, what does that get us? 108 degrees. All right, we're almost done. All right, so now how do I want to find P? What's true about P and what's true about R? What's true about these two angles? They're not the same. I hear you, Ajani. I'm just trying to see if anyone else knows. What should we do? What's true about those two angles? They're opposites of each other inside that four-sided shape. They don't equal each other. They're opposites of each other. What did we just say about the opposite angles? They add up to 180. So these two have to add up to 180. So we'll do 108 plus angle P should equal 180. We should subtract 108. So angle P should equal 72 degrees. And you have found everything.